Hello, in this video, we will be explaining how the PVFC valve and load sense signal works in EHI and OSPE. This is the schematic for OSPE with load sensing dynamic. When the engine is off, the priority valve spool is pushed to the left by the spring of the priority valve. This causes the passage to the EF excess flow port to be blocked, while the passage from the pump P to the OSP spool sleeve set and the EH directional valve spool is open. When the engine is on and the OSP steering unit and EH valve are in the neutral position, the pressure will rise in P until it overcomes the force of the spring in the priority valve and the LS line, which will cause the priority valve spool to move to the right, and oil will be allowed to pass from the pump through the priority valve and out through the EF port. However, there will still be some flow through the dynamic orifice. In other configurations, this excess flow could be connected directly to the tank or blocked in the housing if there is an external priority valve or pressure compensated pump. In the configurator, this is denoted as ET for tank and EB for blocked in the housing. The priority valve is a dynamic type, meaning that flow passes through the dynamic orifice, which is integrated into the priority valve spool, and into the LS line, through the LS orifice, through the LS check valve and PVFC valve, and into the spool sleeve set. When the steering spool is in the neutral position, this dynamic oil flow passes on to the tank. If we had a static system, the pump and priority valve sense a static pressure in the LS line, compared to a dynamic system, where the pump and priority valve sense the boosted pressure in the LS line caused by the spring and small amount of flow through the dynamic orifice. On the left is an example of an EHI with a static priority valve. A static priority valve has no dynamic orifice, so the flow will only be able to pass through the priority valve into the control flow or excess flow lines. In this case, we have a PVFC valve with check valves. On the right is an example of an EHI with a dynamic priority valve, which allows flow through the dynamic orifice to the LS line, as well as through the control flow or excess flow lines. In this case, we have a PVFC valve without check valves. Load sensing steering systems match the flow and pressure requirements of the vehicle. The sizes of the priority valve spring, the dynamic orifice, and the LS orifice all contribute to the standby pressure of the system. In OSPE and EHI, the priority valve spring is usually 7 or 10 bar, 7 for dynamic, 10 for static. The dynamic LS accounts for the 3 bar delta. The dynamic orifice can be 0.6, 0.8, or 0.9 millimeters, and the LS is usually 1 or 1.2. The dynamic flow, standby pressure, and the pressure drop can be calculated using these values. This table shows examples of dynamic flow rates with given spring and orifice sizes. Changing these values allows for more customization. For example, if you wanted to increase the standby pressure, this could be done by increasing the priority valve spring force, decreasing the LS orifice diameter, or increasing the dynamic orifice diameter. As the standby pressure of the system increases, the LS dynamic flow increases as well. The options in the configurator are designed to provide the LS dynamic flow and standby pressures within the typical target range of 0.6 to 1 liters per minute for OSPE below 230 cubic centimeters and 1 to 1.5 liters per minute for OSPE above 230 cubic centimeters, and around 10 to 12 bar, respectively. The PVFC valve is used to resolve between the dynamic flow coming from the dynamic orifice of the priority valve and the static flow coming from the EH valve. When the pressure in the LS line is greater than that in the line from the EH valve, then the PVFC valve will shift to the left until the pressure from the EH valve pushes the PVFC valve back to the right. The pressure will then build back through the LS line until it reaches the priority valve, pushing it to the left and allowing more oil to enter. If we have a PVFC valve with check valves, the PVFC works as a shuttle valve for use with the static OSP and inline EHI. This makes it possible for the LS signal from the EH spool to pass through the PVFC valve back to the priority valve. The check valve in the LS line allows the pressure to build back through, while stopping oil from flowing back through the check valve. This helps to prevent issues such as kickback. Kickback can occur when there is a buildup of pressure on the spool sleeve set. For example, if you have a high pressure in the L or R line and a relatively low pressure in the LS line, then move the spool by steering so that oil can flow through the spool to the gear set. It can cause the steering wheel to spin violently until the pressure in the LS line shifts the priority valve to the left and the pressure from the pump can balance out the external pressure. The check valve in the LS line prevents oil from flowing back through the LS line and therefore prevents kickback. That is everything for this video. Thank you for watching.